Welcome. Here we're going to talk about an application for the area of a circle. So we have the velocity of the flow through a pipe in feet per second is found by dividing the rate of flow, that's cubic feet per second, also written as CFS, by the cross-sectional area of the pipe. Now, a cross-sectional area, that is also going to be in square units, so square feet. Then we have the actual problem statement. If the rate of flow through a 10-inch diameter pipe is 0.95 cubic feet per second, find the velocity. Okay, so we know we're aiming for something that's going to be in feet per second. We're given cubic feet per second, but we're also given inches. So the first thing I want to do is make sure my units all match. So I'm going to convert this. I'm going to divide 10 by 12, 10 inches by 12 inches per foot. And that will give me 5/6 of a foot. So I like to do that first because then all my units match. The next thing I need to do is, I see that this is a area of a circle problem. I need to find my area, which will be the cross-sectional area of a pipe. That'll be the area of a circle. I'm given the diameter, so I need to divide that by 2 in order to find the radius. So the radius is going to be 5/6 divided by 2. That'll be 5/12 foot. I like to keep it in fraction. You can do as you please. 5/12 of a foot is like 0.416 repeating, but I don't like to round until the end of the problem, so I will leave it in fraction form. My scientific calculator will handle it all. It will be no problem as I work through the problem. So the area is pi r squared. I'll plug in my values here, and that will give me pi times 5/12 squared. Do put your parentheses there and then just use the square, and that should all work out in your scientific calculator. And I'll get 0.5454, and then there's some more decimals there, but I'll just leave it there with the 4. So that is the cross-sectional area. That's square feet of my pipe. And the last thing I need to do in order to find my velocity is to divide my cubic feet per second by my area. So if I take 0.95, this is cubic feet per second. And I'm dividing that by 0.5454 square feet. Now, this is the nice thing about problems like this, is you can do unit analysis. So units, you can cancel out exponents the same way you do with variables. And so since I have a cubic up here, the 3 as my exponent, and then a square, a 2 in the exponent for the denominator, I can do 3 minus 2 and end up with just 1 in my numerator. So when I do this, 0.95 divided by 0.5454, I get 1.742. And what I'm left with is a single foot per second. And that is what I wanted in the first place. That is what the problem statement asked me for. So that's one way to assess if you're on the right track with your problems, is if the units work out. If your end answer gives you the units that the problem asked you for. And that is how we solve this problem. Thank you so much for watching.